class. Today we're going to be talking about proportionality. So two quantities are called proportional if the ratio or the scale factor between two variables is equivalent. Just to clean up some vocabulary a little bit. So equivalent means that they are the same, and a ratio, as you guys remember from last year, is a comparison of two quantities. And we've seen this word ratio when we talked about the rational number system. Ratios are equivalent if they have a multiplicative relationship. Multiplicative, so multiplicative obviously coming from the word multiplication. You can analyze a relationship in two ways. You can think of it in a vertical sense, or you can think of it in a horizontal sense. Vertical meaning up and down, and horizontal meaning left or right. And when we talk about up and down and left or right, we're talking about the parts of our ratio. So in a vertical comparison, we are comparing the same quantities of a fraction, so the numerator and the denominator of that same fraction, whereas in a horizontal relationship, we're comparing either the numerators or the denominators of the different parts. So we're going to see if we can find some relationships. Determine if the following relationships are proportional. So let's, for instance, say we're looking at a horizontal relationship. I want to figure out, how do I get from 6 to 2? If I wanted to turn my number 6 into the number 2, how would I do it? Well, I could say minus 4, but remember, we said it's a multiplicative relationship. So let's think, can I multiply or divide to get to 2? Well, yeah, I could divide by 3. If it's a proportion, it better be the same relationship on the bottom as well. Is 24 divided by 3 equal to 8? Yes. So because I'm dividing the same number, yes, that is proportional. Let's hop down to number 2. Let's think horizontal. If I'm trying to get from 1 to 3, I know I can just multiply by 3. So my scale factor in this case would be 3. But if I multiply 5 times 3, do I get 7? Well, no. Which means it's not proportional. Let's think of it in a vertical sense this time. How do I get from 5 to 15? Well, that means I'm just going to multiply by 3. So again, because that scale factor is times 3, let's look on the other side. What's 8 times 3? Well, 8 times 3 is 24. So I should have a 24 on the bottom, but I don't. It's 18. Because it's not the number I'm expecting, it is not proportional. And I would say let's continue with the vertical, but it doesn't look like that's going to work. So let's go the other way. Let's get horizontal again. 6 to 2, or 6 to 12, that means I'm going to multiply by 2, which means I can multiply by 2 down here as well. And it looks like it checks out, so that is proportional. So a lot of this unit ends up not being solely looking at proportions, but looking at word problems and coming up with the proportions from there. So I'm going to read the word problem. I'm going to highlight some key parts that I think are important, and then we're going to see how we can set up some proportions to help us out. Miss Jones decided to drive and visit family over the weekend. After driving for 42 miles, she used 2 gallons of gas. So I'm going to highlight those in different colors. So 42 miles and 2 gallons of gas. Because I did miles in yellow, I'm going to keep that in yellow. And then I'm going to say gallons of gas in green again. So it helps, before we even solve this, to just think of what 2 words we're comparing. So I see a lot of different words in this scenario, but I'm really looking at miles, and I'm looking at gallons. I'm looking at miles, which I highlighted in yellow, and then gallons was green. So my scale factor, my equivalent ratios, well, let's see. What did I put in yellow? So I said it's going to be yellow somewhere, and then green on the bottom. So miles, I had 42. And how many gallons was 42 miles? Oh, 2 gallons. Set that equal to my other ratio, some other ratio of miles to gallons. Well, the other ratio was 84 miles to 4 gallons. And again, gallons was green, so I can highlight these in green. Miles was yellow, so I can highlight those in yellow. And let's check, are these in proportion? Well, if I look at that horizontal relationship, 42 to 84, well, that's just doubling. That's just multiplying by 2. And because I'm multiplying down by 2 here as well, obviously that checks out. There are a couple of spaces for you to fill out a table if you need to, or write down a number line as well. I'm going to leave that up to you guys to decide and to kind of experiment with. I'm going to stick with the word ratio and the equivalent fractions over there. Example number 2. 3 cups of water weighs 12 ounces. So I'm going to say 3 cups of water matches up with 12 ounces. Cool. John says 10 cups of water, make sure I'm matched up, 10 cups of water would weigh 40 ounces. Is that true? Well, I don't know. Let's find out. What 2 things am I comparing here? Looks like cups and ounces. So stick with your word ratio first, cups, and then I'm just going to simplify ounces to OZ. Cups over ounces, if we want to keep color coding, we can, right? Cups we said was yellow. Ounces we said were green. So my equivalent ratios, well, let's pick something with cups. Well, 3 cups. Over how many ounces? 12 ounces. And that's going to be equal to some other ratio of cups and ounces. This case, we've got 10 cups. And we've got 40 ounces. So I want to know, it looks like 400Z, huh? I want to know if these are equivalent ratios. So again, the horizontal relationship doesn't really seem like it's going to work very well. So let's go with this, this vertical relationship. How do I get from 3 to 12? Well, that's easy. I'm just going to multiply by 4. So if that's my relationship, I should be able to multiply these numbers by 4 as well, and it should work out. 10 times 4 is 40. Awesome. It looks like it's a ratio. It is an equivalent fraction, so we're good here. It looks like John is right. Again, there might be an opportunity for you to experiment with the ratio table or the number line, but I'm going to let you guys discover that on your own. Got a couple more, and we will let you guys do some on your own. So next, I've got example 3. The ratio of lemonade mixed to water is 5 tablespoons to 8 cups. So I'm going to start out by just writing down the 2 things I'm comparing. It looks like I've got some number of tablespoons, and I'm comparing that to some number of ounces. So before I even write down any numbers, I'm going to write down, oh geez, that would be awful if I was writing with the highlighter. I'm going to write down tablespoons, and I'm going to write down cups. Tablespoons and cups. Now you could write cups over tablespoons, but I'm going to leave it as tablespoons over cups for right now. So I know tablespoons, the first number I see for tablespoons is 5, over the first number I see for cups was 8. Set that equal to, let's look at how many tablespoons I have. Well, I don't know how many tablespoons I have. How many cups do I have? 64. Okay, cool. So again, my first step is to just figure out, well, I said tablespoons was up top, and then I said cups was on the bottom. So I'm using my color coding, my kind of word ratios to help me out. But I'm stuck in a weird spot because I don't know what is up here. So if I'm trying to represent that as an unknown quantity, well, I could come up with a variable, right? I'm looking for what x is. Maybe I can look at the relationships and figure out what x is going to be equal to. So I don't see a clear way of getting from 5 to 8, so I don't think a vertical relationship is going to work. Let's go horizontal instead. If I'm trying to get from 8 to 64, I remember my times tables and I remember my perfect squares to know that 8 times 8 is 64. So if I'm doing times 8 and that's my scale factor, that means I have to do times 8 up here to get my variable. What is 5 times 8? 40. So this is really telling me that x is equal to 40. Next, we've got some kind of typing example. A fast typist can type 120 words in 2 minutes. So it looks like we're comparing words and we're comparing minutes. Okay, awesome. I've got 120 words over 2 minutes, and that's going to be equal to some amount of words over 4.5 minutes. So do I know how many words? No, it's literally even asking me how many words. So if it's asking you to find something, that's going to be a variable. And then again, I think it's worth it to color code and just make sure that everything lines up nice. So we had words and words. We'll say words are in yellow. And we'll say minutes was in green. Make sure we have everything in green, and all that stuff was on the bottom. So another way to check to see if a horizontal relationship doesn't work, we can always do this vertical relationship as well. So if I'm looking, how do I get from 120 to 2? Or maybe how do I get from 2 to 4.5? I'm going to let you guys think about that. Come back in class and I'll give you the answer to this one. Last but not least, a couple of these missing proportion questions. Again, we don't even need to to set up the word ratios for these because we don't care about the word ratios for these. All we're looking at are just trying to find the relationship. The variable can be all over the place, but the idea is the same. Try to find that vertical relationship. Try to find that horizontal relationship. How do I get from one number to the next? If I'm starting here, so I don't know how to get from 13 to C, but I do know how to get from 5 to 10. That's just a simple times 2. So if that's just a simple times 2, I need to multiply 13 times 2 to get to what C is. In this case, C is whatever 13 times 2 is, and that's 26. I could do the same thing over here. 4 to 12, that's a pretty easy one. 4 to 12 is times 3, which means I need to do something times 3 to get to 27. And I know that 9 times 3 is 27. You could also think backwards. If I gave you guys this same thing, I guess I can erase it, huh? I could also think backwards. Let's go from 12 to 4. How do I get from 12 to 4? Well, it's not going to be times 3 this time. It's going to be divided by 3, which means I need to divide by 3 this way. And again, you get the same answer. 27 divided by 3 is 9. Same thing works when it comes to decimals as well. So in this case, let's go this way. How do I get from 11 to 33? Well, 11 times 3 is 33. So how do I get to what W is? Well, let's just multiply that by 3. Whatever I do to one part, I'm going to have to do to the other part as well. 11 times 3 got me 33, so 0.5 times 3 gets me 1.5. And then I can use the same kind of relationship here as well. If I'm trying to get from 4 to 20, well, that's just times 5, which means I need to multiply the bottom by 5 as well, and we all see that 6 times 5 is 30. There are a couple more practice problems down here below, whether it's the word problems or it's the find the missing parts. I want you guys to take a couple minutes, pause the video, maybe rewind and look at what I did before, and I'll give you the answers to these when I see you in class.